There is a house in Yemen that has been standing for over 300 years. It has survived earthquakes. It has survived floods. It has survived wars. And it was built without a single bag of cement, without a single steel rod, and without a single dollar spent on materials. The walls are thick and cool in summer, warm in winter, and according to structural engineers who have tested samples of the wall material, the compressive strength rivals modern concrete mixes used in residential construction today. That house is still inhabited. A family lives there right now. And if you asked a modern construction engineer how to build something that would last 300 years, they would hand you a quote for hundreds of thousands of dollars and tell you to use materials that, ironically, have only existed for about 100 years. Something is deeply wrong with that picture. Before we go any further, I want you to think about something. You have been taught your entire life that progress means newer, harder, more expensive, more industrial. That concrete is strong and mud is weak. That steel frames are safe and earthen walls are primitive. That the way we build today is the result of centuries of refinement and improvement. But what if that story was never about building better homes? What if it was always about selling more materials? The construction industry globally is worth over $13 trillion per year. $13 trillion. That number does not exist because we need better homes. That number exists because we have been systematically taught to distrust the ground beneath our feet as a building material, even though human beings built with that exact material for 10,000 years before anyone ever heard of Portland cement. And the people who profit from that distrust have worked very hard to make sure it stays that way. Today, we're going to tear that story apart. We're going to look at what mud construction actually is, what it actually does, what the science actually says, and why a building technique that outperforms modern construction in multiple critical categories has been almost completely erased from mainstream education, from engineering schools, and from the conversation about affordable housing that millions of people desperately need right now. Let's start with the basics, because most people have never been given accurate information about earthen construction. When we talk about mud houses, we are not talking about one technique. We are talking about a family of building methods that includes adobe, which uses sun-dried bricks made from clay-rich soil, straw, and water. We are talking about cob, which is a monolithic technique where walls are built up from a mixture of subsoil, sand, straw, and water in continuous sculptural layers with no bricks and no mortar joints. We are talking about rammed earth, which compresses layers of moist subsoil into forms to create walls of extraordinary density. And we're talking about wattle and daub, one of the oldest techniques in human history, where a woven lattice of wooden strips is plastered with a mixture of wet soil, clay, sand, and straw. Each of these techniques has different properties, different appropriate climates, different structural characteristics. But they all share one fundamental thing. The primary ingredient is literally beneath your feet almost everywhere on Earth. It costs nothing. It requires no factory. It requires no shipping container. It requires no supply chain. And when a wall built from it eventually reaches the end of its life, it returns to the Earth with zero toxic residue, zero landfill burden, zero environmental debt. Compare that to concrete. Modern Portland cement production is responsible for approximately 8% of global carbon dioxide emissions every single year. 8%. The aviation industry, which everyone talks about as an environmental villain, account for about 2.5%. The construction materials industry is producing more than 3 times the carbon footprint of every airplane on Earth combined, and almost no one is talking about it in the context of the alternatives that already exist and have always existed. Now, let us address the objections, because you're already thinking them. You have been trained to think them. The first one is water. Everyone says mud dissolves in rain. And this is where the conversation usually ends, because most people have never been told the complete truth about how earthen construction handles water. A properly built earthen wall with adequate roof overhang and a raised foundation does not dissolve in rain. The key phrase there is properly built. A cob wall in Devon, England, a region that receives over 1,000 millimeters of rainfall per year, can stand for centuries. Devon is not a dry climate. It is one of the wettest regions in England. And yet there are cob buildings there that have been continuously occupied for 400 and 500 years. The secret is not waterproofing the wall. The secret is designing the building so water never reaches the wall in sufficient quantity to cause damage. Wide roof overhangs, raised stone or rubble foundations that lift the earthen wall above ground splash. Lime plasters on exterior surfaces that allow moisture to move through the wall while repelling liquid water. These are not modern innovations. These are techniques that builders understood intuitively before the concept of a building permit existed. The second objection is seismic activity. Earthquakes. This one is more nuanced and more interesting because it reveals something that the modern construction industry has never wanted to honestly discuss. Unreinforced adobe, the kind made from simple sun-dried bricks with no internal reinforcement, does perform poorly in major seismic events. That is true, but here is what that statement leaves out. Modern concrete block construction, which is the cheap replacement for adobe in many developing countries, also performs catastrophically in major seismic events. We saw this in Haiti in 2010. We saw it in Turkey in 2023. The buildings that killed people were not earthen buildings. They were poorly constructed concrete and masonry buildings. The comparison that the construction industry wants you to make is between unreinforced adobe and engineered steel frame construction, which is expensive. The comparison they do not want you to make is between unreinforced adobe and the cheap concrete construction that actually replaced it in most of the developing world, which is what people can actually afford. And when you make that comparison honestly, the picture looks very different. Furthermore, modern earthen construction techniques have addressed seismic performance directly. Reinforced adobe, where rebar or bamboo is integrated into the wall structure, performs extremely well in seismic testing. Rammed earth walls of sufficient thickness demonstrate remarkable seismic resilience due to their mass and ductility. Research from the Getty Conservation Institute, from universities in New Zealand, from structural engineering programs in Peru and Chile, all confirms that properly engineered earthen construction can meet modern seismic codes in most regions of the world. But that research is not taught in most architecture schools. It is not included in most engineering curricula. It is not referenced in most building codes. Not because the science does not exist. The science absolutely exists. It is not taught because the system that certifies buildings, trains engineers, writes codes, and approves construction methods is deeply intertwined with the industries that manufacture the materials those codes require. Let us talk about thermal performance, because this is where earthen construction does something that modern construction simply cannot replicate without enormous technological intervention. A thick earthen wall, whether adobe or rammed earth or cob, has a property called thermal mass. This means it absorbs heat slowly during the day and releases it slowly at night. In a hot climate, a well-designed earthen home stays cool during the hottest part of the day without air conditioning, because the walls are absorbing the heat that would otherwise enter the living space. At night, that absorbed heat radiates back, keeping the interior warm. In a cold climate, the same principle works in reverse with appropriate solar design. The wall stores the heat from sunlight and releases it through the night. Modern lightweight construction, the wood frame walls with fiberglass insulation that make up the vast majority of new homes in North America, works on an entirely different principle. It tries to resist heat transfer rather than buffer it. This works reasonably well when the temperature outside stays consistently cold or consistently warm. But in climates with significant day-night temperature swings, which describes most of the inhabited surface of the Earth, thermal mass outperforms insulation dramatically. Studies have shown that homes built with thick earthen walls in appropriate climates can reduce heating and cooling energy consumption by 40 to 70% compared to equivalent lightweight frame construction. 40 to 70% for a resource that costs nothing. The reason this does not become the dominant construction method for affordable housing has nothing to do with performance. It has to do with the infrastructure that exists around conventional construction. Concrete manufacturers, lumber yards, insulation producers, window manufacturers, HVAC companies. All of these industries depend on a construction model that requires their products. An earthen house dramatically reduces or eliminates the need for most of them. That is not a conspiracy theory. That is simply an economic reality. Industries protect their markets. And the most effective way to protect a market is not to suppress a competitor through direct action. It is to make the competitor invisible through the slow strangulation of education, regulation, and professional culture. Think about what happens when a young architect graduates from a 5-year university program. They have spent 5 years learning to specify concrete, steel, glass, and engineered lumber. They have been taught that these materials are the professional standard. They have been taught that anything outside those materials requires special justification, special testing, special approval. The building codes they will work with throughout their career were written around those materials. The liability insurance they must carry is calibrated to those materials. The contractors they will hire know how to work with those materials. The entire professional ecosystem has been built around a set of materials that happen to cost money. And the person emerging from that system has been equipped to be a highly effective participant in that economy, and almost completely useless for building something from the ground they are standing on. This is not accidental. It is the result of decades of industry lobbying, of materials companies funding research institutions, of trade associations writing model building codes, of a slow and systematic process by which the knowledge of how to build with earth was transferred from the domain of common practical skill to the domain of forgotten historical curiosity. Your great-grandparents knew how to build a house from the ground. Your grandparents probably still knew someone who did. You almost certainly do not. That knowledge was not lost because it became irrelevant. It was lost because someone made it economically inconvenient for it to be relevant. And yet it persists. In New Mexico, there are adobe homes that have been continuously occupied for over 200 years. In the Drave Valley of Morocco, multi-story earthen kasbahs have stood for centuries in a climate that produces both intense heat and significant rainfall. In the Shurbam district of Yemen, a city sometimes called the Manhattan of the desert, earthen skyscrapers up to 11 stories tall have defined the skyline for 500 years. These are not curiosities. These are proof of concept at a scale that modern construction professionals should be embarrassed to ignore. And the movement to reclaim this knowledge is growing. In Europe, particularly in France and Germany, earthen construction has experienced a genuine revival. The Charité Institute in Grenoble, France, has spent decades conducting rigorous scientific research into earthen construction techniques and training architects and builders from around the world. In the United Kingdom, the organization Earth Structures has worked with planning authorities to develop a clear regulatory pathway for modern earthen construction. In the United States, organizations like the California Earth Art and Architecture Institute have been fighting for decades to get earthen construction included in mainstream building codes, with some success in specific regions. New Mexico, Arizona, and California have earthen building codes. You can legally build an adobe home with full permits in those states. And when you look at the resale values of historic adobe homes in Santa Fe, you find something interesting. They are not cheaper than conventional construction. They are often more expensive because people recognize intuitively that there is something valuable and irreplaceable about a building that has stood for a century and a half. It shows no signs of stopping. The market knows something that the construction industry does not want you to know. Earth builds value. Earth builds permanence. Earth builds health. The indoor air quality of earthen homes deserves its own conversation. Earthen walls naturally regulate humidity. Clay absorbs excess moisture from the air when humidity is high and releases it when humidity is low, maintaining interior humidity levels in the range that is most comfortable and most healthy for human beings. Modern synthetic materials, paints, adhesives, and engineered wood products off-gas volatile organic compounds for years after installation. The air inside a conventionally built modern home is often more polluted than the outdoor air in a major city. An earthen home with natural plasters and finishes produces none of those off-gas compounds and actively improves air quality through its hygroscopic properties. Fire resistance is another area where earthen construction simply ends the conversation. Earth does not burn. There is no combustible material in a rammed earth wall, an adobe wall, or a cob wall. In regions where wildfire is an increasing threat, this matters enormously. The fires that devastate communities do not stop at earthen walls because earthen walls give them nothing to consume. You could surround a cob home with burning material, and the walls would remain standing. The roof and interior fittings would be vulnerable, but the structural envelope itself is essentially fireproof in any real-world fire scenario. At a time when entire neighborhoods are being erased by wildfires, the construction industry is still building with wood frames and calling it progress. What would it actually cost to build an earthen home today? This is where the numbers become genuinely radical. The material cost for an earthen home is close to zero if you have access to appropriate soil on or near your site. Labor is the primary cost, and labor in earthen construction can be community labor. Historically, building in earth was a communal activity. Neighbors helped neighbors. Communities built together. The concept of a barn raising exists in American culture because that model of collective construction was normal within living memory. It can be normal again. Owner-built earthen homes in the United States have been completed for total material costs of between $5,000 and $30,000 for modest single-family dwellings, depending on region, size, and finish quality. Compare that to the median cost of new home construction in the United States, which now exceeds $300,000 for the structure alone before land costs. We have created an economic system in which the most basic human need, shelter, requires the average person to enter a 30-year debt relationship with a financial institution. And we have done this while sitting on top of the material needed to solve that problem, which is literally the ground. The people who benefit from the current system are not going to change it. The mortgage industry, the construction materials industry, the real estate development industry, they all depend on housing being expensive. Expensive housing is not a bug in the system. It is the feature. The question is whether enough people can recover the knowledge, the skills, and the legal pathways to build outside that system. And the answer, increasingly, is yes. Not through any dramatic revolution, not through any single legislation, but through the quiet and persistent work of people who have decided that they would rather spend their lives in a home they built from the ground than in a debt they bought from a bank. The 300-year mud house is not a relic. It is a blueprint. It is a reminder that the most durable things human beings have ever built were not built with the most expensive materials. They were built with the deepest knowledge. And that knowledge, buried under a century of industrial propaganda, is still there. In the soil, in the old buildings, in the hands of the people who never stopped building the way their grandparents taught them. You just have to decide you want to find it.